Hi, and welcome to the first video workshop created by the Foothill College ISRI. This workshop will focus on the basic concepts and applications of machine learning, without diving into the technical details or math behind it. Before we get into that, I want to talk a little bit about the ISRI. ISRI stands for Independent Student Research Initiative. We are Foothill College's student-run research organization. The primary thing we do is try to help students do research projects for college credit through the Independent Study Program. If that sounds like something you'd be interested in, please sign up to get more information at tiny.cc/myisri or foothillisri.com. This is the first of a planned series of lectures on various research topics. We believe that machine learning can be helpful for research projects, so that's why we decided to produce a workshop on it. First of all, what is machine learning? You may have heard it thrown around recently as it's become a big buzzword in business. Machine learning is a part of artificial intelligence, which is the science of getting computers to replicate human behavior. According to Arthur Samuel, an American computer scientist, machine learning gives computers the ability to learn without being explicitly programmed. Machine learning leans on methods from various advanced fields of math, including statistics, calculus, and linear algebra. Understanding the mathematical foundations for machine learning will give you insight into how the algorithms work and help you decide which models to use. However, it's entirely possible to use machine learning to solve problems without knowing exactly how it works. This is because of the availability and accessibility of machine learning libraries, which are libraries of machine learning models developed by experienced professionals. One such library is scikit-learn, which we will explore in future workshops. Why is machine learning such a big deal all of a sudden? In recent years, we've had a huge explosion in the sheer amount of data available to people. For example, companies like Google, Facebook, and Amazon log lots of information about who you interact with, what you purchase, and what you like and dislike, among other things. Machine learning can help us efficiently deal with all this new data and find interesting patterns in it. You can find examples of machine learning in almost every sector today. For example, Netflix uses machine learning to recommend new shows to you. Siri uses machine learning to recognize your voice. PayPal uses machine learning to detect fraudulent transactions. This workshop is designed to introduce you to machine learning since it can be used for a variety of research projects in both STEM and social science fields. We can divide machine learning into two major subfields: Supervised ML and unsupervised ML. Supervised machine learning feeds a bunch of data to an algorithm, lets it learn from that data, and tries to help the algorithm predict the outcome of an unknown situation. For example, say you wanted to train a machine learning model to predict if a mole is cancerous or not. You would need a bunch of previous data, probably a bunch of images of moles, and would need to know whether the mole in each picture is cancerous or not. By feeding this data to the computer is able to learn what characteristics of the image indicate cancer. For example, if the mole has irregular edges, that may be a sign of cancer. Once the machine learning model is done being trained, you can give a new picture of a mole, and the model will predict whether that mole is cancerous or not. The other subfield of machine learning is unsupervised ML. In unsupervised machine learning, we give the algorithm a bunch of data, but don't tell it to predict anything in particular. We just try to get the computer to find correlations or associations in the data that humans might not have been able to pick out. For example, a business might want to group their customers into specific categories that exhibit similar buying patterns. In our workshops, we'll likely focus more on supervised machine learning for now, because of its applicability to research projects. Within supervised learning, there are two major kinds of problems: classification and regression. In a classification problem, we want to predict an output variable that is categorical, meaning that it belongs to a finite set of classes. For example, we might want to predict if someone has a certain disease or not, or if someone's tumor is malignant or benign. The other kind of problem is regression, where we want to predict a real valued or continuous output. This usually means that our output is a number. For example, how can we predict the selling price of a house based on information about it, like how many bedrooms and bathrooms it has? What will be the cost of a certain healthcare operation for an individual? Here's an example of a classification problem in machine learning. We are given a data table representing 3 people and information about their SAT score, GPA, whether they have legacy to a college, and whether they get into college or not. By the way, the data in this table is completely made up. A bit of terminology. Each row besides the first row is called an observation. So we have 3 observations in our data set. For example, Mary, who has an SAT score of 1450, a GPA of 3.6, and doesn't have legacy to a college. Mary gets into college. That's one observation. These items in our first row are called variables. We have 4 variables in our dataset: SAT score, GPA, has legacy, and gets in. The gets in variable is the one that we want to be able to predict. Similarly, here's an example of a regression problem. We have 5 different houses and information about how many bedrooms they have, how many bathrooms they have, and when they were built. In this example, we are trying to predict the house price. When we create a machine learning model, we need to reserve some part of our data to test how well the model performs. One common data split is to use 80% of the data for training the model and the remaining 20% for testing. Going back to our regression example, we might use data from 4 of the houses to train the model and test the model on the remaining house. However, since we only have data from 5 houses to work with, we wouldn't really get a great indication of how well our model performs. In our next workshop, we'll teach you what to install to actually use machine learning algorithms. We'll also teach you how to create and test a machine learning model for a simple classification problem.